In this lesson, I'll show you 12 examples on how to assign oxidation states. The question reads, assign an oxidation state to each atom in each compound. Let's start with question A. We have Cl2, chlorine gas. Cl2 is a diatomic molecule made up of two calcium atoms bonded together. And because of that, the oxidation state of both calcium atoms is 0. Therefore, the oxidation state here is equal to 0. Next we have the sodium ion. Since sodium is a monatomic ion, the oxidation state of sodium will be 1+. Next we have potassium fluoride. The oxidation state of potassium, K, is 1+. And the oxidation state of fluorine is 1-, so we'll write down -1. If we treat this like a mathematical equation and we add +1 to -1, we'll end up with 0. So the oxidation state here is 0. And I want to mention that you would expect that since this compound is neutral. It carries no charge. Next, in question D, we have carbon dioxide gas. Let's begin with oxygen, and I want to treat this like a mathematical equation. The oxidation state of oxygen is 2-. And we have 2 of them, so I'll multiply 2- with 2. That gives me -4. Next, we have to deduce the oxidation state of carbon by recognizing that the sum of oxidation states of all atoms in a compound must equal to 0. So, what number added to -4 will give you 0? That number is +4. In question E, we have the polyatomic anion sulfate. And if we treat this like a mathematical equation, the oxidation state of sulfur plus the oxidation state of oxygen should equal to -2. We know the oxidation state of oxygen, it's 2-. So I'll write down -2, and we have 4 of them. Multiplying these two out, we end up with -8 is equal to -2. What plus -8 will give you -2? That's easy, it's +6. Therefore, the oxidation state of sulfur is +6, and the oxidation state of all the oxygen atoms combined is -8, or individually -2. Finally, in question F, we have potassium oxide. The oxidation state of potassium is 1+, according to rule number 4, and that's shown on your screen. You'd ordinarily expect the oxidation state of oxygen to be 2-. But rule 4 takes priority. What we have to do is deduce the oxidation state of oxygen by setting the sum of all the oxidation states equal to 0. So starting with potassium, we have 1+, and we'll multiply that by 2, plus the oxidation state of oxygen, which we don't know, multiplied to 2, is equal to 0. 2 times +1 is 2, plus 2, and we don't know what this is, so we'll call it x, is equal to 0. Solving for x, bringing this 2 over, we have 2x is equal to -2, and then dividing both sides by 2 gives us x is equal to -1. Therefore, the oxidation state of oxygen in this compound is -1. If you would like to see the answers to question number 2, make sure you watch part 2 of this video, and I'll go through each of these like I did in question number 1. We'll see you soon.